Well, it's been almost a year since the derecho swept across the Midwest last summer. As recovery continues, a Husker researcher is working to improve grain bin structures to better withstand severe weather in the future. Well, Christine Wittick with the University of Nebraska-Lincoln joins us now for an update on that effort. And Christine, thanks for your effort here joining us this morning. So why did you decide to look into the damage that was sustained specifically by grain bins last year?
Absolutely. Thanks so much for that question, Janet. So in short, it's to do my part to help make our communities much more resilient to extreme weather. For all of my career as a structural engineer, I've largely been focused on how we can take our individual structures, our infrastructure systems, and now our communities and make them more resilient to natural hazards. And when we look at communities in general, recent studies have shown that rural communities tend to be a lot less disaster resilient compared to their more urban counterparts. And a large part of that is due to the reliance on the agricultural industry and the very unique structures that support it. Notably, or one of which, is the steel grain bin. And the design and construction of these bins varies quite substantially. And so a lot of data is needed for us to have a good understanding about how they're going to perform in future events. And unfortunately, this event, this past summer's derecho, presented the opportunity for us to do that. And so a team of us from UNL went out to survey about 7 regions, a total of over 500 individual bins, to provide us with that data to understand how these structures fail in light of all the potential variations.
So describe the vulnerability specifically of grain bins in this severe weather condition.
Absolutely. So grain bins, as you're likely familiar with, are cylindrical, thin-walled steel structures anchored to a concrete pad. When these are empty, they're particularly vulnerable to high winds. The thin cylindrical walls can buckle under the wind's pressure. The anchorage can also fail, which can be particularly dangerous as the structure can now impact everything that's around it. Grain bins can also fail when they're full or partially full. And one of the ways that we saw this in the field several times was failure of tear-off of the entire or part of the roof, exposing all of the material that's being stored and leading to potential contamination.
So Christine, what are the next steps in this research effort? And are we maybe going to have a new style grain bin on the market anytime soon?
Absolutely. Thanks for that question. So what we're currently doing is trying to build probabilistic models. So based on all this real-world data, can we say the probability that a given grain bin in its location, with its design and construction, what's the probability that that's going to fail given certain wind speeds? And this type of predictive model is really important due to all the variations so that we can help make those best recommendations for how to build this structure better. And in addition to looking just at the individual structure, which is our focus right now, thinking a lot bigger picture, we're collaborating, interdisciplinarily with sociologists, with economists, with community members to help understand what are the best disaster mitigative solutions that we can recommend to enable an entire agricultural community to withstand future hazards.
All right. Well, Christine, thanks for sharing your insight with us today. Assistant Professor of Engineering with the University of Nebraska-Lincoln, Christine Wittick, joining us again today. You can learn more. Go online to wittick.unl.edu.